Okay, now today's topic is numerical problem based on dimensional analysis. Yesterday we have done a few problems relating, that is based on the relation between different physical quantities. Now a few more problems today I will do. The question is frequency of vibration of a stretched string. You might have seen the wire fitted in sitar and guitar. It's nothing but a stretched wire. So when you pluck it, now the string vibrates with some frequency. Now frequency of vibration of a stretched string depends upon, the first factor is, that is length of the wire. Length of wire. The second factor is mass per unit length and tension force. I am writing first tension force and mass per unit length. Mass per unit length. Per unit length of the wire. Now obtain a relation between these physical quantity with the help of dimensional analysis. So with the help of dimensional analysis, obtain relation between them. A relation amongst them. So what will be the relation? So frequency of vibration of a stretched string nu depends upon length of the string. So dimension, that is the power of length, is not known to us. Okay, let the dimension be A. And this also depends upon tension force. So you can use tension force symbol as T or F, whatever you like. So I am using T or F, okay, writing F raised to B. And then it varies with mass per unit length, small m raised to C, where m stands for mass per unit length. So if the string has length L and its mass is capital M, then what is mass per unit length? Capital M by capital L or small l. So then mass per unit length, small m, is nothing but capital M, total mass of the string, divided by its length. This is mass per unit length. Now L, length of the wire, stretched wire, and F is the tension force. Okay, these are the physical quantity upon which frequency of vibration of a stretched string depends. Okay, so you can just combine all these. This is L raised to A, F raised to B, then M raised to C. So then nu is equal to, this implies nu equals to some constant K, L raised to A, F raised to B, and then M raised to C. Okay, consider it as equation 1. Then, now putting the dimension of each term in LHS and RHS. So we are just substituting the dimension of nu. You all know dimension of nu is what? 1 by T. So this is T minus 1. M naught, L naught, T raised to minus 1. This side. And RHS, there is no dimension for K, and then L raised to A. So L raised to A means this L, and then F is force. So force is ml T minus 2 raised to B, okay, and then mass per unit length, which is m by L. So should I write m L raised to minus 1, m by L raised to C. Now just take the terms which have equal bases. Okay, m raised to B, L raised to A, L raised to B, L raised to minus C. So should I write L raised to A plus B, L raised to A plus B minus C. Then T only one, T raised to minus 2B. And this side it is M naught, L naught, T raised to minus 1. Now using the principle of homogeneity. So principle of homogeneity of dimension tells that the powers of equal bases are equal. Yeah? Yeah. Two terms are there. M raised to B, M raised to C. So it should be B plus C. Yeah, you are right. B plus C. B plus C. Right, B plus C. Okay. Now see, T raised to minus 2B, here T raised to minus 1. So first I equate the smaller one power. That is minus 2B is equal to minus 1. So what is B? It's 1 by 2. Now the moment you get B, you can equate the power of M, which is B plus C is equal to 0. So B plus C is equal to 0. So what is C? That is minus B, that is minus half. So once you get BC, you can get A by equating the power of L. So here L is to 0, here L is to A plus B minus C. So just equating the power of L, that is A plus B minus C is equal to 0. So A is what? C minus B. Now what is C? Minus half, and then B is half. So this is minus 1 only. So you are getting A also. Now from equation 1, use this equation 1. So from equation 1, which is nu is equal to K L raised to A. So what is A? Minus 1. Then F raised to B. B is 1 by 2. Okay, half. Then the third term is T. T raised to, no T, that is M. M raised to C. C is minus half. So should I write K by L and then F raised to half by M raised to half? So in one term you can write F by M, square root of F by M. That is tension force and mass per unit length. And this is L, length of the string. So these are the factors upon which nu depends. Frequency of vibration of a stretched string depends upon this factor. That's why different wires in sitar and guitar have different lengths, and tension force in different wire are kept different. At the same time, mass per unit length. So some of the wire may be thin, some wire may be thick. Material of the wire, that also matters. If the wire is made up of copper, steel, different material, then accordingly the mass per unit length will be different. So that's why. So nu equals to K by L under root F by M. Regarding the constant K, dimension cannot say anything. So your final answer should be nu is equal to K under root. With the help of dimension analysis, we are getting this final relation. Okay, take a written. If you have written, then take the snapshot. I will rub the board. Taken? Okay. Now, solving the another question. Number 2. Number 2. So the frequency of vibration of a tuning fork vibration of a tuning fork depends upon, the first factor is length of the prongs. Prongs means, you might have seen tuning fork. How many of you have seen this? No one has seen. You might have seen, you might have seen fork in your home, similar to fork, but it has only two prongs. Two prongs. These are called prongs. This is called a stem. Okay. So depends upon the length of the prongs. So what is the length of the prongs? And second factor is Young's modulus of elasticity of this material. So depends upon Young's modulus of elasticity. And third factor is density of the material of the prongs and density of the material of tuning fork. Tuning fork. Am I right? So this is the scenario. Frequency n of a, it's single n, no? Tuning, Tuning. Yeah. So length of the prongs, Young's modulus of elasticity, and density of material of tuning fork. Tuning fork means of what material the tuning fork is made up. So then their density, that also matters. Tuning fork may be made up of iron, steel or copper, or so many materials are there. So depends upon density of the material also. Okay. Now this is the condition. So we can write frequency nu depends upon length of the prongs, but dimension is not known to you. Young's modulus, Y. Remember, Young's modulus of elasticity is nothing but a stress by strain. A strain has no dimension because a strain is change in length by original length. So it is dimensionless quantity. But a stress, which is deforming force per unit cross sectional area, that stress has dimension similar to that of pressure. So stress has dimension same as that of pressure. Then Young's modulus raised to B, Y raised to B, and then the third factor is density, D raised to C. Now you have to correlate them, that is obtain the relation between the physical quantity given with the help of dimensional analysis. Obtain a relation amongst them with the help of dimensional analysis. Dimensional analysis. So we can rub this lower part, yeah. So then you can just combine all the three. Nu proportional to L raised to A, Young's modulus raised to B, D raised to C. So nu is equal to some constant K, L raised to A, Y raised to B, and D raised to C. This is Y. The same Y. Okay. Now just assume it as equation 1. Now putting the dimension of each term in LHS and RHS. Now we are putting the dimension of nu, which is m naught, L naught, T raised to minus 1. And this side K has no dimension, L raised to A, and then Y, Young's modulus. So Y is a stress by strain, a stress divided by strain. As I told you that a strain has no dimension, so dimension of a stress, whatever is the dimension of a stress, that will be the dimension of Young's modulus. So a stress is force by area, cross section area. So the same as that of pressure. So force is mlt minus 2 divided by area is L square. So finally you are getting ml minus 1 T minus 2. This thing I have done it in the previous class, that is dimension of some physical quantity. There I have already derived the dimension of Young's modulus. And then Young's modulus, we are putting the dimension ml minus 1 T minus 2, similar to that of pressure, raised to B, and then density, you know, mass by volume. So mass by volume is nothing but L cube raised to C. So this I can write. So this is m naught L naught T raised to minus 1, and see m raised to B, m raised to C. So it's how much? M raised to B plus C. Now L raised to A, L raised to minus B, and L raised to minus 3C. Okay? So then L raised to A minus B minus 3C. Am I right? The power of L is A minus B minus 3C. And then one more term is T. T raised to minus 2B only. Minus 2B. Now equating the principle of homogeneity. Using the principle of homogeneity of dimension, we are equating the powers of equal bases. So first of all, I would like to equate this one because this is a smaller one. So minus 2B is equal to minus 1. So minus 2B is equal to minus 1. So what is B? It's 1 by 2. Now the second one is B plus C. So B plus C is nothing but 0. So C is equal to minus B. This is minus half. And then once you get B and C, you can find A by equating the power of L. So power of L is A minus B minus 3C, and here it is 0. So A minus B is half, then 3C is minus 1 by 2 by volume. Okay, this is equal to 0. So A equals to half minus 3 by 2. Am I right? So it's minus 1 minus 2 by 2. So this is minus 1. A equals to minus 1. Now using relation 1. From equation 1, what you get? Nu equals to K L raised to A. Then Y raised to B. Y means half. And then D raised to C. C means minus half. So the final result is K by L under root Y by D. Y for Young's modulus, D for density. So the new frequency is equal to K by L under root Y by D. I am writing the final result here. So finally the relation comes as nu equal to K by L under root Y by D. Young's modulus by density. So this is the relation. Okay. So this type of problem normally comes in annual examination or in half yearly examination or your PT1 or PT2, whatever. So from dimensional analysis, one question comes from this portion only. So you have to take care of this portion, and then we are doing some different types of problem. Just take the snapshot. I will rub the board. Yeah. Taken. Okay. Now starting from van der Waals equation of state. So do you know what is van der Waals equation? Van der Waals equation is P plus A by V square into V minus B is equal to RT. So this is the relation. Read. Yeah? van der Waals. If it is n mole, then nRT. Okay. So n is the number of mole. This is P plus A by V square. This P stands for pressure. A and B are constant. V for volume, R universal gas constant, and T the temperature expressed in absolute scale. Yeah, symbols are well known to you. P for pressure, I am writing here P for pressure, V for volume, volume of gas, T for temperature, R universal gas constant, universal gas constant, and then T for temperature, absolute temperature, absolute temperature. So absolute temperature doesn't means absolute zero. Temperature expressed in Kelvin scale is called absolute temperature. Now the scenario is you have to find the dimension of A and B. A and B are constants. A and B are constants. So the question is, find the dimension of A and B. So just to solve such types of problem, the logic behind it is, the fact is, you can add physical quantity of same dimension only. You can subtract physical quantity of same dimension only. Okay. So physical quantity having same dimension can only be added. Physical quantity having same dimension can only be subtracted. But multiplication and divide, they may have different dimensions also. But for addition and subtraction, it is necessary that the two quantities must have the same dimension. So then, if P is pressure, A by V square must have the dimension of pressure. So to find the dimension of A, we are equating A by V square is equal to P. So A equal to P into V square. Now you know the dimension of pressure. We have just written the dimension of Young's modulus, a stress. So whatever is the dimension of a stress, that is the dimension of pressure, force by area. So force is ml t minus 2, mass into acceleration, and then area is L square, this is pressure, into V, V for L cube, and then square it. So you are getting m, L raised to minus 1, T raised to minus 2, and then L raised to 6. So finally you can write m, L raised to 5, T raised to minus 2 is the dimension of A. Now this is volume. So the B should have the dimension of volume only, because you can subtract something, that is this must have the dimension of volume. So B is equal to V, and V is nothing but L cube. You may write m naught L cube T naught. Okay. So this way you can find the dimension of A and B. Now once you know the dimension of this physical quantity, you can solve another type of problem also. Like, I am starting another problem. Pressure P is equal to B minus x square by A into T. Okay, P is pressure, x for distance, T for time. Now you have to find the dimension of B and A. P for pressure, x distance, and T for time. Now what are the dimension of A and B? A and B are constants. So what are the dimension of A and B? This is the question. So how will you find the dimension of the physical quantity A and B? Now see, this is B minus x square. So this term has dimension of L square. So the B must have the dimension of L square only, because Physical quantity of same dimension can only be subtracted. So if x has dimension of L square, that is x square, then what should be the dimension of B? So B must have the dimension of x square, that is L square only. You may write m naught L square T naught also. That m naught L square T naught also. Okay. Now this is L square divided by AT is equal to pressure. So pressure P is equal to, this has the dimension of L square divided by AT, A into T. From here you can find A. So this implies A equals to L square by pressure into time. So this is L square, and what is the dimension of pressure? You have written the dimension of pressure. Pressure is, m L minus 1 T minus 2. So this is m L minus 1 T minus 2, and then time T again. So finally you are getting m raised to minus 1. See, L raised to 2 and L raised to minus 1. If you bring it in numerator, then it will be L raised to plus 1, L raised to 3. Good. And then T raised to minus 2 into T, that is T raised to minus 1. Now bring it in the numerator. So this becomes T only. Am I right? So this should be the dimension of A. And if the question is find the dimension of A by B, okay, divide A by B. Find the dimension of A into B. You can just multiply them. You can get. Okay. Take the snapshot. Taken. Okay. So now the next part is, okay. Right first. Written. Still clear, no? Now I am writing about the next question. Now the equation numbering, I think earlier was 4, no? So it should be 5. The earlier question, what should be its number? 4. Fourth one. Yeah? This one will be 5th. Okay. So this V is equal to, if it is AT square plus BT. Now V is for velocity, T for time. Find the dimension of A and B. Now the question is, find the dimension of A and B. Okay, this side V is velocity, V for velocity. So this V and AT square. So if this is velocity, this must have the dimension of velocity. So just equate AT square is equal to V, AT square equal to V. So then what is A? This is V by T square. Now dimension of velocity, all of you know, LT minus 1, but this is T square. Okay. Take it in the numerator, this is LT raised to minus 3. Am I right? And this BT should be equal to V only. BT should have the dimension of V, and then B equals to V by T. So V is LT minus 1 by T. This is LT minus 2. So these are the dimension of the physical quantity A and B. Okay. Now, if I ask you a question, that is pressure P is equal to A minus T square by Bx. P for pressure, T for time, X for distance. So every time need not write P. What is P? Pressure. What is X? Distance or length, whatever, and T for time. Now find the dimension of A and B. Find the dimension of A and B. So how will you find A and B? And then finally find the value of A by B. Also find A by B. ये भी बताना. Then this is T, time, T square. So A must have the dimension of T square. So A should be equal to T square because time is square, so must be subtracted from time square. So A equals to T raised to 2 only. Okay. Then this is T raised to 2. This is pressure. So pressure P is equal to T square divided by B into X. So tell me what is B. So then B equals to T square divided by P into X. Okay. This is T square divided by pressure can be written as this pressure is ml minus 1 force by area. So force is mlt minus 2 by L square. So this is ml minus 1 T minus 2. Am I right? For pressure, and this is L. So finally you are getting m raised to minus 1, then L will cancel out, then T raised to minus 4, T raised to 4 is for B. Now tell me what is A by B. Okay. So just to find A by B, now A is T square divided by B is m raised to minus 1 T raised to 4. So finally it is m raised to plus 1, that is T raised to how much? Minus 2. Yeah. M T raised to minus 2. M T raised to minus 2. So this is A by B. Okay. Now take the snapshot. I will rub the board. Going for the next question. Going for the next question. Taken? Okay. Now, next part is seven. Question number 7. Pressure P is equal to A root T minus Bx square. Now you have to find the dimension of A and B and then find A into B. Find A into B. Means first you have to find the dimension of A and B and then multiply the dimension of A and B. Finally, you have to find A into B. Okay. So this is pressure. A constant, B constant, T time, X distance. Okay. So this P is equal to A into root T. Because if this side is pressure, this must be pressure. This must have a dimension of pressure. So pressure minus pressure is equal to pressure only. So P should have dimension A is equal to A under root T. So what is A? That is pressure by under root T. So pressure is ml minus 1 T minus 2 divided by under root T means T raised to half. You just adjust them. That is m L raised to minus 1 T raised to minus 2 minus half. So tell me it is how much? Minus 2 minus half. So finally you are getting ml minus 1 T raised to minus 4 minus 1, that is minus 5 by 2. This is for A. Now B. This term should have dimension of Bx square. So Bx square has the same dimension as that of P. So what is X square? What is B? B equal to P by X square. Now pressure is ml minus 1 t minus 2 divided by L square. So just solve it. Simple mathematics can lead the result. So that is m L raised to minus 3 and then t raised to minus 2. So you have both a and b. Now finally you have to find a into b. So a is ml minus 1 t raised to minus 5 by 2 and then b is ml minus 3 t raised to minus 2. So just write here, this is m raised to 2, yeah, m raised to 1, m raised to 1. So this is m raised to 2, then L raised to minus 1, L raised to minus 3. It's how much? L raised to minus 4 and then t raised to minus 5 by 2 and then minus 2. 2 to the 4, minus 5, minus 4, minus 9 by 2. Minus 9 by 2. Yeah? M raised to 2, t raised to minus 4, L raised to minus 4, t raised to minus 9 by 2 or something different. So just see, just check the result, check it. Yeah? T raised to minus, t raised to 2 to the 4, minus 5, minus 4, minus 9 by 2. Okay. So it's minus 9 by, yeah. For a, yeah, you can ask. No, yeah, there are some quantity like angle. Angle has unit but no dimension. There are certain quantity. Number of moles, it's a number, it has no dimension. It's a number. Number of moles is what? 12 gram of carbon contains how many number of atoms? 6.023 into 10 raised to 23 atoms. Okay. So you are asking about dimension of seven fundamental unit all have dimension. All have dimension. So mole is represented by MOL. Yeah, ampere for A, temperature for K. So these are the representation. So your question is, yeah, it should have dimension. If it is a 7 fundamental, then it must have the dimension. 7 fundamental, it must have the dimension. Okay. How will you define mole? Okay, I will explain it later on. I should continue for the remaining part. This can be asked. So the next question is, now force force F is equal to A by root x plus bx plus cx square. Now I have force, x distance, distance. You have to find the dimension of A, B and C. Find the dimension of A, B and C. This is the question. Find the dimension of A, B and C. So how will you find? Yeah, this is force. So this term should have the dimension of force only. So force F is equal to A by root x. So what is A? F root x. So F is MLT minus 2. And then root x is, that is under root L. So L raised to half. L raised to half. So this is M 2 plus 1, 3 by 2. L raised to 3 by 2 and then t raised to minus 2. Now similarly, what is the dimension of B? So Bx is equal to F. So what is B? This is F by x. Now force is MLT minus 2 divided by x is L. So this is mt minus 2. And finally, the last part is cx square is equal to f. So cx square is equal to f. So c is equal to f by x square. So f means mlt minus 2 divided by L square. So what you get? ml minus 1 t minus 2. So this way you are getting the dimension of A, B and C, all the three quantities, A, B and C. And if I ask you what is A into B by C, so finally you have to find, suppose the dimension of A into B by C, then what should be its answer? What should be its answer? A into B by C. So you have the dimension of A, dimension of B and dimension of C. So A into B, just multiply them and then divide it by the dimension of C. So your result will be, yeah, take the snapshot, rub this upper part. Okay, taken a snapshot. Okay, now we are going to find A into B divided by C. For the same question, the next part is, if you are going to find A into B by C, so what is the dimension of A? A is ml 3 by 2 t raised to minus 2 into B. B is mt minus 2 divided by C part ml minus 1 t minus 2. So you can cancel one of them and then m, see L raised to minus 1, L raised to 3 by 2. So it's how much? L raised to 3 by 2 plus 1. So L raised to 3 by 2 plus 1 and then t raised to minus 2, and if you bring it, this will cancel out. So okay, t raised to minus 2 only. So finally you are getting m L raised to 5 by 2 and then t raised to minus 2. Am I right? M L raised to 5 by 2 t raised to minus 2. T raised to minus 2. Okay? So should I rub it? Now if the unit of force the next question is, I don't know the number. What was the number of last question? Yeah? What was 8? 8. This, oh, this is 9. Okay. So the question is, if the unit of force, is kilonewton, 1 kilonewton, okay? So kilonewton, that of time is millisecond, that of time is millisecond. So should I write in bracket? Millisecond. And that of power kilowatt, and that of power kilowatt, kW. 1000 watt is equal to 1 kilowatt. Now what would be the unit of mass and length? The question is, what would be the unit of mass and length? This is the question. What would be? Okay. So force is ml. If the unit of force is kilonewton, this is kilo. K and kilonewton. That of time is millisecond. Millisecond I have written in bracket. and that of power is kilowatt. That of power, kilowatt. Then what would be the unit of mass and length? You know force F is equal to mLt minus 2. Okay. So what is the power of m? Should I write like this? And this is equal to 1 kilonewton. Means 1000 Newton. 1000 Newton. Now time t, so power of t is 1 and is equal to 1 millisecond. So this is how much second? Yeah, millisecond means 10 raised to minus 3 second. And the power p is equal to, so what should be the dimension of power? Work by time. So work is ml, power p is equal to energy per unit time or work done per unit time. So work is ml t minus 2 into L, ml square, t minus 2 divided by t. So power dimension is ml square t minus 3, t minus 3, ml square t minus 3. So for power we are writing ml square t minus 3 and is in kilowatt, 1 kilowatt, that is 1000 watt, 1000 watt. Okay. Now equation 1, equation 2, equation 3. Just divide equation 1 by equation 2. Equation 1 divided by 2 implies that. So F by T is how much? 1000 by 10 raised to minus 3. So first you write F by T means F is mLt minus 2 divided by T. mLt minus 2 force divided by T. So you get mL T minus 3 and is equal to 1000 by 10 raised to minus 3. So this is 1000 by 10 raised to minus 3. Should I write 10 raised to 6? 10 raised to 6 Newton second. Newton second is the unit. Newton per second. Not Newton second, Newton per second. So assume it as equation 4. Equation 4. And then 3 divided by 4. 3 divided by 4. So what you get? 3 is, this is mLt minus 3 divided by this term. So 3 divided by 4 means 3. Write first ml square t minus 3 divided by 4 is mLt minus 3. mLt minus 3 is equal to, now this 3 is 1000 watt divided by 4 is 10 raised to 6 Newton per second. So what you get? Finally you are getting a number that is equal to 10 raised to minus 3. And this side m will cancel out, l will cancel out, and then t raised to minus 3, t raised to minus 3 will cancel out. So you are getting only L. Yeah. So this implies L is equal to 10 raised to minus 3 meter. This much meter. So L is 10 raised to minus 3 meter. Now I can, okay, take the snapshot. I will rub this upper part. I will rub the upper part. Taken the snapshot. Okay. Now putting the values of L and T in equation 1. Now we are putting the value of L and T L and T in equation 1. So what is our equation 1? M L T raised to minus 2 is how much? 1000. Now L you have already find 10 raised to minus 3. So then M is equal to 10 raised to 3, that is 1000, divided by L T raised to minus 2. So 10 raised to 3 divided by L is 10 raised to minus 3. And then T is 10 raised to minus 3 second. So into 10 raised to minus 3 raised to minus 2. So this much kg. So you are getting 10 raised to 3 divided by, here it is 10 raised to plus 6. 10 raised to plus 6 by 10 raised to plus 6 and 10 raised to minus 3. So you are getting 10 raised to 3 in the denominator. And finally you are getting 1 kg. So what is the value of M? M comes to be 1 kg. So this way you can find the value of M and value of L. T already given, that is 1 millisecond, that is 10 raised to minus 3 second. So need not to find T. Okay. So interesting one. This question is